Good evening all. Am I audible? Good evening everyone. Am I audible? Venkateshwaran, good evening. Niranjan, good evening. So what about the assignments? Have you all submitted your assignment? Your third assignment and as well as second assignment? So let us wait for a few minutes. Pai Sharma, good evening. So you can drop your replies in the chat box. What about the assignment? Have you all submitted your assignments? Still I found around 60 members I think have submitted their second assignment. Okay, shall we start the class? Pavan Kumar, good evening. Okay, so today's topic is we are going to build an web server using ESP8266. So today we are going to learn step-by-step guide that shows how to build a standalone ESP8266 web server that controls two outputs, which is two LEDs. This ESP8266 NodeMCU web server is mobile responsive and it can be accessed with any device with the browser in your local network. This part shows you how to create a web server to control two outputs using Arduino IDE, and you can use this method to create a different web server to fulfill your needs. If you do any projects, you want to create a web server, you want to build a web server in the sense, you can just modify the code and you can customize your own web server. So, shall we move to the coding part? So today is 16th day. Try to submit your third assignment within Friday. At Friday's class, I will provide you the 15th day assignments Google form. So please try to submit your assignments within Friday. Don't take too much of time. Submit your second assignment and third assignment as soon as possible. So now let's move to the coding part. So I'm going to explain the code today. Okay. So very first, as usual, library. We have to include library. here we are going to use only one library, which is ESP8266 Wi-Fi. So today we are going to only build a web server, right? So we only need Wi-Fi library. So this line includes ESP8266 Wi-Fi library, which provides the necessary functions to connect to a Wi-Fi network and create a web server. So then we have to give network credentials. One is SSID of your Wi-Fi and password of your Wi-Fi. So this line declares a constant character array variable named SSID and assigns it the value pantech SF. This is my Wi-Fi SSID. So this represents the name of the Wi-Fi network you want to connect to. So then password. So this line declares a constant character array variable name password and it assigns to some value. This represents the password required to connect to the Wi-Fi network. And coming to this, which is Wi-Fi server, inside as a parameter I passed 80. So this line creates an instance of the Wi-Fi server, class name server, and assigned it to port 80. So this set up a server on the ESP8266 board that listens for incoming HTTP request on port 80. By default, we always give 80, right? You have already seen in the before classes, we have defined the same thing, which is 80. So then coming to string header. So this line declares an empty string object name header. So this variable will be used to store the HTTP header of incoming request. And then this string output 5 state, which is off, and string output 4 state, which is also off. So this line declares a string object name output 5 state and assigned it the initial value, which is off. So this variable will keep track of the state of an output connected to GPIO pin, which is 5. So here we have taken two GPIOs, one is 5 and another one is 4, which is nothing but D1 and D2 for two LEDs. So then this line, this line declares a string object name output 4 state and assigned it to the initial value, which is off. So this variable will keep track of the state of an output which is connected to the GPIO pin 4. Then I declare the pin number. So this line declares a constant integer variable name output 5 and assign it to the value 5. This represents the GPIO pin number to which an output device is connected, as well as 4. So this line declares a constant integer variable named output 4 and assigned it the value also 4. This represents the GPIO pin number to which another output device is connected. And then this line, unsigned long current time, which is equal to millisecond. So this line declares an unsigned long integer variable named current time and is assigned the value returned by the millisecond function. So this function returns the number of millisecond elapsed since the board started running. And then unsigned long previous time, I am initialized this one as 0. So this line declares an unsigned long integer variable name previous time and assigns it to the value 0. This variable will be used to store the previous value of current time for comparison. So and then constant long timeout, which is equal to 2000, which is nothing but 2 seconds. So this line declares a constant long integer variable name timeout time and assigned it the value of 2000. So this variable represents the timeout period in milliseconds. So it is used to determine if a connection has been inactive for too long. If the difference between the current time and the previous time exceeds this value, in the sense this connection is considered timeout. So this is all about the declarations. And coming to void setup function. Inside setup function, first I have declared the baud rate, which is 115200. So this line initializes the serial communication at the baud rate of 115 to 00. So it is used to communicate with the computer or other devices through the serial port. And then I have declared the pin number and its mode. So pin mode output 5, which is output. This line sets the mode of GPIO pin 5. So specified by the output 5 variable as an output. So it configures the pin to be able to provide or receive a signal. Similarly, output 4, this line sets the mode of GPIO pin 4, which is specified by the output 4 variable as an output. So then this line, digital write of output 5, which is set to low. So this line set the initial state of the GPIO pin 5 to low, which means the connected output device will be turned off initially. Same for output 4. This line sets the initial state of GPIO pin 4 to low. And then what I have done is serial print of connecting to. So this line prints the string connecting to the serial monitor. It is used for debugging and displaying information. Then I am going to print my SSID and I am going to start Wi-Fi begin using SSID password. So this line prints the value of the SSID variable, which is the Wi-Fi network name, to the serial monitor on a new line. And this line Wi-Fi.begin inside SSID and password. So this line initiates the Wi-Fi connection process with the specified SSID, which is network name and password. So the ESP8266 board will attempt to connect to the Wi-Fi network. And as usual, while loop. So this while loop is for Wi-Fi connection checking, and this line starts a while loop that continues until the Wi-Fi connection is established. So the condition, which is Wi-Fi dot status equal to WL connected, checks if the board is not connected yet to the Wi-Fi network, and then I gave a delay of 500 milliseconds. So this line causes a delay of 500 milliseconds. It passes the execution of code within the loop to allow time for Wi-Fi connection to be established. And then serial print of dot. So this line prints a dot to the serial monitor to indicate that the connection process is in progress. So then these lines, we have to print the IP address, right? So first serial print ln blank. So this line prints a new line character to the serial monitor. Moving to the cursor to the next line. And then this line prints the string Wi-Fi connected to the serial monitor, and then it prints the string IP address to the serial monitor, and then this line serial.println Wi-Fi.local IP. So this line prints the IP address of the ESP8266 board to the serial monitor, and the Wi-Fi.local IP function retrieves the IP address assigned to the board after it has successfully connected to the Wi-Fi network. And then coming to this line server.begin. So this line starts the web server, allowing to listen for incoming HTTP request on port 80. So once this function is called, the board is ready to handle web request. And then void loop. So inside loop function, first one is Wi-Fi client, which is equal to server dot available. So this line checks if there is a client connected to the web server. If a client is available, then it creates a Wi-Fi client object name client to handle the communication with that client. And then if condition. So this line check if the client object is valid and represent a connected client. So inside I have printed first, I am going to print like new client. So this line prints the string new client to the serial monitor to indicate that a new client has connected. And then this string current line. So this line declares an empty string object named current line. So it will be used to store the current line of incoming data from the client. And then current time, which is equal to millisecond function. So this line updates the current time variable with the current value of milliseconds. Since the board started running, it is used for tracking the elapsed time. And then previous time, which is equal to current time. So this line assigns the value of current time to previous time. It is used to keep track of the previous time to compare with the current time later. Then another while condition. So this line starts a loop that continues as long as the client is connected and the elapsed time, since the previous time is within the timeout threshold. So inside, again current time which is equal to millisecond function. So this line updates the current time variable with the current value of millisecond. It is used to keep track of the elapsed time within the loop. And this line checks if client not available. This line checks if there is any data available to the read from the client. And if something is available in the sense, this line reads a single character from the client and store it in a variable called C. Its data type is character. So now I am going to write that particular data using serial.write. So this line writes the character C to the serial monitor. It is used for debugging and displaying the received data. And then header plus or equal to C. So this line appends the character C to the header variable. So it is used to build up the complete HTTP header received from the client. And then another if condition. So this line checks if the character C is a new line character, which is indicating the end of the line in the HTTP header. Inside this if condition, there is another if condition. Current line dot length, which is w equal to 0. So this line checks if the current line variable is empty, which indicates that the current line is empty and marks the end of the HTTP header. So inside this print lines like first is client. So this line sends an HTTP response status line to the client indicating that the request was successful, which status code 200, and the server is returning a valid response. And coming to this line specifies the content type of the response as HTML. So it informs the client how to interpret the data in the response. And this line prints, it informs the client that the connection will be closed after the response is sent. So after the response is sent, the connection will be closed. So this allows the client to understand that it should not send any more requests using the same connection. So client.println. So this is used to send an empty line, which is a new line character in the HTTP response. So again inside there is another if condition. So this line checks if the request path stored in the header variable, right? So contains the string get 5 on. So this index of function returns the position of the specified string within another string. And if the string is not found, it returns 1. And inside I am going to print like GPIO5 is on. So this string print to the serial monitor indicating that the particular pin, which is 5, is being turned on. And then this line updates the output 5 state variable to store the state on for GPIO5. And then I am going to make that particular GPIO high, which turns the output connected to that pin. Then another condition, which is else if. So this line checks if the requested path contains the string and inside it print like the particular pin is off. So this line prints the string GPIO5 off to the serial monitor, indicating that the GPIO5 output is being turned off. And then this line updates the output 5 state variable to store the state off for GPIO5. Then I am making the particular GPIO low again. Then another else if condition which is for GPIO4. So this line check if the requested path contains the string. If yes, in the sense it will print the line like GPIO4 is turned on to the serial monitor, which is indicating that the particular pin is being turned on. And then coming to this line, this also updates the output 4 state variable to store the state on for GPIO4. And then I am making my GPIO4th pin as high. Another else if condition for 4th pin turn off. So this line checks if the requested path contains the string, and if yes, in the sense it comes inside and prints line like GPIO4 is off on the serial monitor, which is indicating that the pin output is being turned off. And this line updates the output 4 state to store the state off for GPIO4. And then I am making my pin as low. And then this is for the web page designing using HTML and CSS web page designing line. So this first line, client.println, and this line. So this line sends an opening HTML tag for the document type declaration, which is document type.html. So I am opening the HTML tag to the client. It indicates that the following content is an HTML document. And then this line, client.println, this line starts the head section of the HTML document and sets the viewport metadata. The viewport meta tag specifies how the content should be displayed on different devices and ensures the initial scale, which is set to 1. And this line. So this line adds a favicon to the HTML document. So the link tag, this tag, the link tag with the rel which is equal to icon. So attributes specify the location of the favicon. In this case, it set the favicon as an empty data URL. So on next line, this line defines an inline CSS style for the HTML document. You can customize your own page using like whatever you want, like the background color, what type of font it will show, everything and all. So it set the font family to Helvetica, makes the content display as an inline block. Centers it horizontally using marginato and aligns the text in the center. Where you want to place that content, in the center or left side, right side, everything. You can customize your own page. And coming to this line also defines a CSS style for a class name button. So it set the background color to that particular color using this line. This is the code for the color. It removes the border and sets the text color to white and adds padding to the button. And this line is also continuous the CSS style for the button class. It set the text decoration to none, which means no underline. Set the font size to 30 pixels and add a margin of 2 pixels and set the cursors to the pointer when hovering over the button. And this is for button 2. So this line defines a CSS style for a class name button 2. It sets the background color to that particular color using this code, which is a shade of grayish blue. And this line closes this line. This line closes style tag and head section of the HTML document. It signifies the end of the style declarations and the beginning of the document's body content. And coming to this line starts the body section of the HTML document and adds an H1 heading with the text like ESP8266 web server. This heading will be displayed as the main title of the web page. And then this line adds a paragraph element to the HTML body. It displays like the text like GPIO5 state followed by the value of the output 5 state variable. It is in on state or off state. And the value of output 5 state represents the current state of the GPIO5 and will be dynamically inserted into the HTML response. And now another if condition. So if this particular pin is off, in the sense this line checks if the output 5 state variable is equal to off, it is used to determine the state of GPIO5. So if yes, in the sense it coming to this line, and if output 5 state is off, this line is executed. So it sends an HTML paragraph element containing a link. Clicking on this link will trigger a return request to turn the particular pin on, the GPIO5 pin on. So this link is styled with the CSS class button. So else, if it is not true, in the sense this will come to this line, right? So if the output state of 5 is not off, this line is executed. So indicating that output 5 state is on or some other value. And then coming to this line, and this line is executed when the particular 5th pin is not off. So it sends an HTML paragraph element containing a link element. Clicking on this link will trigger a request to turn on that pin off. So this link is styled with the CSS classes button and button 2. And then it coming to this line. So this line sends an HTML paragraph element that displays the text like GPIO4 state followed by the value of that particular output 4 state variable. So the value of output 4 state represents the current state of the GPIO4 and will dynamically inserted into the HTML response. So another condition for checking on or off. So first it check if that particular 4th pin is off. So this line check if that output 4 state variable is equal to off. It is used to determine the state of the GPIO4. If yes, it doesn't, this coming to this line and it sends the HTML paragraph element containing a link element. By clicking on this link will trigger a request to turn on that particular pin on. So this link is styled with the CSS class button. Else, so if the output 4 state is not off, in the sense this line is executed indicating the output 4 state is on or some other value. So this line executed when the output 4 state is not off. It sends an HTML paragraph element containing a link element. Clicking on this link will trigger a request to turn on the GPIO4 to turn off. The link is styled with CSS classes button and button 2. And this line sends the closing tags for the body and HTML elements indicating that end of the HTML content. And this line sends an empty line, which is a new line character in the HTTP response. It separates the HTML content from the rest of the response. And this break, this statement, this line exits the while loop, effectively ending the process of the client request. And then else, inside else there is a current line which is equal to set to nothing. So this line resets the current line variable to an empty string. It is executed when non-empty line is encountered. So indicating that the current line is not the end of the HTTP header. So it comes to else if. So this line is part of the inner while loop and checks if the character C is not equal to the carriage return character. So it comes to this line. If the condition is true, this line appends the character C to the current line string. It concatenates the current character to the existing line string. And then coming to this line, header which is equal to empty string. So this line resets the header variable to the empty string. So it clears the accumulated HTTP header. So and then coming to client.stop, this line closes the connection with the client, freeing up resources associated with it. And then it print a line like client disconnected. So this line prints a message to the serial monitor indicating that the client has disconnected and that lost another empty string. So this line prints an empty line to serial monitor for better readability. That's it. So this is all about our coding side. Is it clear, everyone? Is it clear? Shall we move to the connection part? Is it clear, everyone? If it is clear in the sense, please drop S in the chat box. Let's move to the hardware connection. Attendance link will be provided in few minutes. I am asking, is it clear or not? Yeah. Okay. After finishing the class, just try to do this by yourself. Give it a try, then only you get to know. Okay, so now let's move to the hardware section. So here the connection is very simple. We only need two LEDs. One is for GPIO 4 and another one is for GPIO 5, right? Here I have connected two LEDs with 2.2k ohm resistor. So one end of the LED has to be, the negative side of the LED has to be connected with the ground pin of ESP8266 and as well as this side too. And the positive side of the LED has to be connected with, first LED has to be connected with D1 and second one has to be connected with D2, right? So that's it. This is our connection. So now let's upload the code into a microcontroller. So let me upload the code. Make sure that you have selected the correct board and port. So now let's upload it. Yeah, it's uploading. So make sure that you have selected the correct baud rate, and if I press reset button here, wait a minute. Yeah, Wi-Fi has connected. So here it is your IP address. What you have to do is that you just note this IP address and go to your browser. You just need to type this IP address and your web server will open. So ours is 192 dot, here just type 192.168.2 and the last one is 118. So instead of this, click 118. Just click enter. So here you will get your web server. This is what your web server looks like. So this is our heading, ESP8266 web server and GPIO file, GPIO 4. Here now our state is in off state. So if I click on, our LED has to become on, right? So fourth LED is on. If I click on, our fourth LED is blinking. So if I click off, LED is off. On, off. I think my fifth LED has burned. Sorry for this, my LED has burned here. So this is not working right now. So I turned on this, LED is turned on. So similarly, you can see the same output in your here also. Here it will print like GPIO4 on, client is connected, new client. So let me show you. So if I turned off this in the sense, here it will show like GPIO4 is off. Now I turn on, show like turn on. Similarly, fifth state is on, fifth state is on. You will get the same output here. You will get your new client host, your IP address and connection and everything and all. So this is your output. Is it clear, everyone? Is it clear, everyone? If it is clear in the sense, just please drop S in the chat box. Is it clear? So you can also customize your web server using some other components, like you can add a button and you can add your sensors also. So give it a try. You can try this same code by yourself also. Just take the same code here. Just change your SSID and password. Just try it by yourself. You just need only your microcontroller, LED resistor and jumper wires, right? Yes, you can work the same code for ESP32 also. ESP8266 and ESP32 are similar, right? So you can also try it in ESP32 also. It is possible. What about the remaining numbers? Is it clear, everyone? So when I am telling, don't make delay. Please try to submit your second assignment as well as third assignment before Friday. So don't take too much of time. Try to submit it within Friday. And 23 you will get your fourth assignment. As well as the same day itself you will get your Google form also. So 23 is our last class, right? Today is already 16th. So please try to submit all your assignments within Friday. So is it clear, everyone? Do you have any doubts in this sense? You can ask me. Is it clear? Do you guys have any doubt? So okay, this is all about today's session. Let's catch up at tomorrow with next topic. So thank you all. Have a great day.